Hello, friends. Once again, welcome to my chemistry class. In our last class, we talked about electrolysis and we defined electrolysis. We talked about electrolyte. We defined electrolyte. I gave you different types of electrolyte: strong electrolyte, weak electrolyte, non-electrolyte. And we went further to talk about anode, cathode, and so on and so forth. And we also talked about electrolysis of acidified water. So we are not going to deliberate on those aspects again, though we will still be mentioning them in the course of our studies today. Our today's lesson, I want to start with electrolysis of concentrated copper 2 tetraoxosulfate 6, as it is written clearly. Electrolysis of concentrated copper 2 tetraoxosulfate 6 solution using carbon or platinum anode. The aim of this electrolysis of this reaction is to deposit copper, solid copper, from the solution and the gas. So we are going to see how it can be done. Note that the copper 2 tetraoxosulfate 6 is a salt, as you have seen it here, reacting it with water, dissolving it with water. So this is copper 2 tetraoxosulfate 6. When you dissolve it in water, the ions that will be present in that electrolyte are shown below. Here you have cation. I believe you remember what I said about cation. You also remember what I said about anion. So cations are those ions that are positively charged. So this is the cation from here. This is the cation from here. Now when you get those cations, you now go for anions. This is the anion from this. This is the anion from this. Having known that, the next is the concentration of ions. You need to know whether the ion is concentrated. For you to do well in electrolysis, check the concentration of the ions in the electrolyte. Know which one is of higher concentration and which one is of lower concentration. Also check about the nature of electrode. Here they have told you carbon and or platinum. They are the electrodes that we are using in this case. They are inert electrodes. They are not reactive. So when you know those two, now you can now consider their positions in the electrochemical series, which I have taught you before in one of those classes I treated before today. So go back there and check what I said. Watch the video on what I said about the position of ions on the electrochemical series. They are there. So you will now consider which of these are they close by or are they far apart. These two, are they close by or are they far apart on that electrochemical series? From there, you now know what to do. Good. Now let's move forward to what will happen at the anode and at the cathode. Anode, remember I told you anode is what? Positive electrode. So I will say at the anode, now At the anode, remember anode is positive electrode. The two ions that are negatively charged will move to the positive electrode. Remember, like charges repel, unlike charges attract. Since anode is the positive, then you will have the negative ions going close to it. And remember also that this is what we are talking about now is something like this. So this is electrode, this is another electrode, this is the wire connected to the electrode. This is your electrolyte. In this your electrolyte, you have dipped the two electrodes. One is positive and one is negative. This is your source of battery source. This place is your battery source. Now, when you connect the battery into it, the four ions, this and this are here. This is positive, this is negative. The negative is cathode. The positive is anode. So now, since this is anode that I've written there, know that the negative ions, these two will migrate to the anode, while these two will migrate to the cathode. Now, when two of them migrate to the anode, now you check their consider, since we are using platinum electrode or carbon electrode, they are non-reactive. They will not influence the discharge of ions. So it will just be neutral to the decision. Then they will now be the one that will fight and then struggle on which of the ion that will be discharged in preference to which other one. So now, when these two negative ions move to the anode, consider them. You will see that if you check that electrochemical series that I gave you in that class, you see that they are far apart. They are not close by on that series. They are far apart. So since they are far apart, we will not consider the position. Sorry, the concentration. We will consider the position. Position will dominate. Position will take the lead. Now, on that series, as far as this and this are not close by, this one will be discharged in preference to this. This will remain in the solution. This one will leave. So I will now write OH minus at the anode will give out the electron. This minus you are seeing here is the electron, excess electron it has. It will give out that electron to form OH group. This is that electron. So it is in the solution. It will give that electron to the electrode, and the electron will flow upward in this direction and then enter back through cathode. Now you have this. This is after it has donated the electron. It turns this and is still inside the solution. Remember that there are so many of them in that solution. Another one will do the same simultaneously and then still form this. Then two of them will react. Then we now have OH plus OH to give you H2O plus O plus O. Yes, H2O, water, it will still remain there, plus O. Remember, there are so many of them that will undergo this same reaction. And now you have O, which is oxygen atom. Another oxygen atom is also produced by another two of these OH. Then the two oxygen atom will react to form O2 gas. That's the bubble you will observe bubbling out at this place. You see bubbles. coming out, coming out. That's the bubble. You see bubbles coming out at that electrode. That bubble is what? Oxygen gas that is being produced. Where? At the anode. Now let's see also what will happen at the cathode. So at the cathode, cathode is negative. So these two positive ion, one from copper 2 tetraoxosulfate 6, another from water, they will migrate also to this negative electrode and they will hustle on which of them will be discharged in preference to which of them. And then you will now see that here we will also check their position and their concentration. Now, if you check that electrochemical series that I gave you, you will discover that their position are not far apart. They are very close. They are very close. Immediately as you are coming down, when you pass this, you meet this. So they are very close. So we will not consider what position like what we did at the anode. So since they are very close, we will consider the one with higher concentration. The solution will discharge the one with higher concentration in preference to the one with lower concentration. And now, how do I know the one that is of higher concentration and how do I know the one that is of lower concentration? If you check the heading, they told you electrolysis of concentrated CuSO4. This concentrated CuSO4 is letting you to know that CuSO4 is of more concentration than water in that solution. This is of more. So if this is more in the solution than this, that means this is also more, this is also more than this and this. So now we are considering this and this. This is of higher concentration than this. So it is going to be the one that will be discharged. So now we will have Cu2 plus in this solution will move down here. Those electrons that are flowing down, it will obtain 2 because it has lost 2 electrons. So it will collect back 2 electrons. Remember I told you E minus stands for electron. So it will collect back 2 electrons to form Cu. This is solid copper. And since it is solid, unlike oxygen that was a gas here and it bubbles out, so this is solid, it will not bubble out. Instead, it will stick itself on the electrode. They will keep sticking themselves as they are collecting electrons. They are becoming part of the electrode, making that electrode to be bigger and heavier than before. Assuming you have taken the mass before you start this reaction, after some times, remove the cathode, check again, and you will discover that weigh it again, you will discover that it will be heavier than before because some amount of copper was deposited on that electrode. So they are not part of the solution again. The oxygen are not part of the solution again. So that's what happened at the anode and at the cathode. Now, what you need to also observe is the electrolyte. What happens to the electrolyte? Now, the solution lost hydroxide ion and also lost copper. So the solution still retains hydrogen and sulfate 6 ions. So that means that the solution that you started, which was CuSO4 solution, this is salt solution, will gradually turns to H2SO4 because these two are leaving the solution, leaving back this one. These two are still there. Now it will gradually return to H2SO4 solution. You can see that this is a salt. This is a salt. And this is an acid. Gradually, the same solution is changing from salt solution to acidic solution. So, what will happen in this solution is that since the color of this solution will be changing gradually from blue, the color will be fading away. It will be fading because Cu is blue. Cu2 plus is blue in color, and the solution from the beginning was blue in color. But with time, because Cu is leaving the solution, the color will gradually be changing, fading away. At some point, what again that will happen to that solution? Remember, what happens to it, since the solution is gradually turning to acidic solution. Now remember, in electrolysis of acidified water, we saw that hydrogen and oxygen were liberated from the solution, causing the solution to be more acidic with time. So at some point, this one, after copper has been given out from the solution turns dilute solution of tetraoxosulfate 6, and what will be deposited at the anode, at the cathode, will change. Anode will still be oxygen, but cathode will be hydrogen. It will not be what? Copper again. It will start, because the solution is what? Acidic solution. Copper will stop and hydrogen will start, because at some point hydrogen will be of higher concentration. It will now start to be given out. So here will be oxygen going out, here will be what? Hydrogen going out, whereby increasing the concentration of that dilute solution that you were using. So the solution of this will continue to increase. I believe you enjoyed the lesson. Subscribe to the channel. More are still coming. Share it to your friends. Like the channel. Watch all the videos. Don't just jump in and start watching one and then maybe just watch all. You will not regret watching them. See you some other time.